Hello, and thank you for tuning into the Math Guy. Today we'll be looking at the law of cosines. Our first problem today reads, given that lowercase b equals 5, lowercase c equals 3, and capital A equals 40, we need to find lowercase a. Now this problem is very similar to the law of sines, and that what we simply do is just plug everything in and calculate it out. The only difference is we have to use a different formula. If we have a case like we do here, where we draw this triangle out, we have angle A, we know side B and side C. We need to find this side down here, which is side A. Whenever we have a case like this, we have to use the law of cosines. Okay? Whenever we're looking at two sides and the included angle, to find the third side, we have to use the law of cosines. To use the law of cosines, the formula looks a little bit more difficult, more in-depth, tricky. Some people think it's harder, but it's actually easier to work with. The formula for this would be a squared equals b squared plus c squared minus 2 times b times c times the cosine of capital A. Looks longer, looks harder, but it's a piece of cake. Right? So all we want to do here is simply plug in everything we know. If we look, we need to know b, c, and capital A. Well, we know b, c, and capital A. This helps us find lowercase a, which is what we want to find. So plug everything in that you know. We know that lowercase b is 5, so we have 5 squared, plus c squared, where c is 3, so we have 3 squared, minus 2bc, so it's 2 times 5 times 3, times the cosine of capital A, which is 40. So we go through and start simplifying everything down that we know. We have a squared still, that stays as it is. 5 squared is 25. We have 3 squared, which is 9. 2 times 5 times 3 is 30. And if you do on your calculator the cosine of 40, we get 0.766. The next thing we have to do, combine like terms and do any multiplication we might have. So a squared, once again, stays as it is. 25 plus 9 is 34. 30 times 0.76 gives us an answer of 22.98, and it's still a subtraction problem. So now we have a squared equals 34 minus 22.98. A squared, when we have a squared, we simply have to find out what a squared is. It's 34 minus 22.98. We do the subtraction, we get 11.02. To find out what a is, we take the square root of both sides. We get that a equals 3.32. Sorry about that. Now this formula can also be used for calculating with right triangles as well. The only thing is, when you use a right triangle, if capital A is a 90-degree angle, it turns into the Pythagorean theorem. So you can actually use this as another way to work with right triangles, but it only really lets us use sides. Our other problem for today looks just like this. We have a diagram of a triangle. We need to find a missing angle. This is a non-right triangle. I'm going to tell you that right now. It's a non-right triangle. So what we have to do, if you look, we have 3 sides, we're missing an angle. If we have 3 sides, we're missing an angle, the only thing we can do is use the law of cosines. Okay? If we have 3 sides, we're finding an angle, use the law of cosines. If we had 2 sides, an angle, and we're finding another angle, we might be able to use the law of sines for that. Okay? But in this case, we have to use the law of sines. Whenever you have 3 sides and a missing angle, the law of cosines is what you have to do. So, in order to use this though, we need to actually apply labels to everything. So we're going to say that this is angle A. If this is angle A, then this is side A. We can say this is side B, and we can say that this is side C. So A equals 3, B equals 7, C equals 5. So we plug all this into our formula, which is a squared equals b squared plus c squared minus 2bc cosine of A. We plug it all in. Well, a squared, which is 3, so we have 3 squared, equals b squared, so we have 7 squared, plus c squared, which is 5 squared, minus 2 times 7 times 5 times the cosine of A. plug all this in, we start simplifying down piece by piece. 3 squared is 9, 7 squared is 49, 5 squared is 25, minus 2 times 7 times 5, we get an answer of 70, if we do all that. So we have 70 cosine of A. We can't do anything with this cosine of A because we don't know what capital A is. So we have 9 equals 49 plus 25 minus 70 cosine of A. Now we want to go through the next and we want to combine like terms. So the 9 stays as it is. We have 49 plus 25. Those are the only terms we can combine together at this point. Okay? If you're wondering why, because the 70 is 70 times the cosine of A. We can't combine the 70, this negative 70, with the 74 at this point. We have to do some other math first to get this negative 70 cosine of A by itself. So we have 9 equals 74 minus 70 cosine of A. Now, we want to get this cosine of A by itself so we can find out capital A. Because that means we have to remove this 74 from both sides first. On the right-hand side, the 74's cancel out, so we have negative 70 cosine of capital A. 9 minus 74 is negative 65. So we have negative 65 equals negative 70 cosine of A. Now we want to get this cosine of A by itself. We have to undo the multiplication. We do that by dividing. So we divide both sides by negative 70. The negative 70's cancel out. So that means on the right-hand side we have cosine of A by itself. Negative 65 divided by negative 70 is 0.929. So we have 0.929 equals the cosine of A. And to find out what the angle is, we have to use the inverse function of cosine. So we do cosine inverse, okay, cosine of the negative 1, of 0.929 equals capital A. When we do cosine inverse of 0.929, it gives us the value of capital A. And we're told that capital A equals 21.72 degrees. Thank you for tuning into the Math Guy. Remember to check back soon for more videos by me.